Introduction to databases. The objectives of this lesson is number one, to know the potential problems with lists. So lists are what we create maybe using Microsoft Excel. Number two, understand the reasons for using a database. Why do we use a database? Why not Microsoft Excel? Number three, understand how related tables avoid the associated problem with lists. Then number three, learn the components of a database system. 4, learn the elements of a database. And then learn the purpose of database management system. And understand the functions of a database application. So this will be the objectives of this lesson. So before we take a look at the anomalies or the list, what's wrong with the list, let us first take a look at the purpose of a database. So the purpose of a database is, number one, to store data. So it is just like, for example, your bag. You store your things inside your bag. And then of course, why do we store? So that later on we can actually retrieve this data. Then number two, to provide an organizational structure for data. So the data that we store should be organized. That's why we place them inside tables. And maybe there are indices, etc. So it provides the organizational structure. The number three, to provide a mechanism for querying. So how do we retrieve? How do we create? So create data. How do we modify and update our data? So these are the purpose of database or purposes of a database. A database can store information and relationships that are more complicated than a simple. So in a list, each row is intended to stand on its own. So just like in Microsoft Excel. As a result, the same information may be entered several times. So what do I mean by that? So for example, we have a list of projects that may include the following columns in an Excel. So you have the project manager's name, the ID of the manager, the phone number, etc. So if a particular person is managing 10 projects, his or her information might appear in the list 10 times. So we have 10 names of the particular person and of course 10 IDs of that particular person in the list. So here's an example of a list. So we have project manager, manager ID, phone, project name, project ID, start date, and budget, for example. So you can see in the project manager, so Pedro, 1, 2, 3, 4, has 4 projects. Pablo has only 1 project, and Ambrosio have 2 projects. That's why we can see also their manager ID. So the Pedro's ID is repeated 4 times, etc. And of course their phone number is the same. And then we have the project name, the project ID, start date, and the budget. So list of modification issues. Redundancy and multiple themes in lists create modification problems. So these are what we call deletion problem, update problems, and insertion problems, or in databases sometimes we call them the deletion anomaly, update anomaly, and insertion anomaly. Let's again take a look at our list. So what if we change the project manager of project number 1 to Ambrosio? So if we change that, you notice, then we still have to change the manager ID and the phone number. So I'm referring to project number 1. So if we change this, you should also change this and change this, because of course this is not the manager ID of Ambrosio, and this is not the phone number of Ambrosio. So we have to change all of this. So what if in the process of changing, for example, you were able to give the wrong phone number or maybe the wrong manager ID? The number 2, so that's the what we call the update anomaly. What if we delete project manager 2? So if we delete project manager 2 or project number 2 rather, so if we delete this project, what will happen is the record of Pablo will also be deleted, and that will make let's say for example is a manager, so that will remove Pablo from the list because he has only one project. And what if we need to insert a new project but no manager is assigned yet? So sometimes it will not be allowed. But if we really have, what if we really have to do that? So then we have in our list of project managers, we have a blank manager. So these are what we call update, delete, and insertion anomalies. So addressing information complexities. A relational database or relational databases are designed to address many of the information complexity issues that arise in business. A relational database stores information in tables. Each informational theme is stored in each own table. So in essence, a relational database will break a list into several parts. One part for each theme on a list. For example, we have an employee table and we have a department table. Putting the pieces back together. In our relational database, for example, we broke apart our list into several tables. Somehow the tables must be joined back together, and you will be learning more of this as you go on. In a relational database, tables are joined together using matched pairs of data values. So we separate them, but we can also join them later. But we are going to join them not actually physically, only logical joining of the tables. With that, we separate them, then we join, so it sounds like more work and not less. So relational database is much more complicated than a list. However, a relational database minimizes redundancy. That's why we don't have repeated names, repeated phone numbers, etc. Preserves complex relationship among topics and allows for partial data. Furthermore, a relational database provides a solid foundation for creating user interface forms and reports. Structured query language, so SQL or SQL, is an international standard language for creating, processing, and querying databases and their tables. The vast majority of data-driven applications and websites use SQL to retrieve, format report, insert, delete, and or modify data for users. So let's say for example, if you're using Lazada, if you're using Facebook, so these are all making use of databases. Database system. So there are 4 components of database systems: the users, the database applications, the database management system or the DBMS, and of course the database itself, the physical database. So here are the users, and the users, you can see, make use of the applications. And the application, so we are interacting with the applications, maybe the user interface. But the program is interacting with the database management system, which in turn is interacting with the physical database. So users or a user of database will use a database application to keep track of information. So for example, if we're using Facebook, we're using Lazada, we're using Shopee, for example, then we are considered as users. So we use different user interface forms to enter, read, delete, and query data. So if the web page or what we see on the screen is what we call the user interface. And of course, for admin, they may be using another user interface. And then of course, we can produce reports using this interface or using this application or using the applications. Then the database is a self-describing collection of related records. So it is where we store data, as we have said last time. Self-describing because the database itself contains the definition of its structure. And metadata are data describing the structure of the data in the database. So we have data that describes the data in the database. That's the metadata. Tables within a relational database are related to each other in some way. So database contents, so we have the user data, then we have metadata. So what are metadata did? Again, these are data that describes the user data. So maybe what are the columns, etc. What are the fields? These are the metadata. And then we have the indices and other overhead data. So maybe we have the data for sequence numbering, etc. And then we have some applications metadata also. So these are the contents of a database. Database management system. A database management system serves as an intermediary between database applications and the database. So it's something between the database applications and the database, as we have seen in our previous image. So the DBMS manages and controls database activities. The DBMS creates, processes, administers the data that it controls. So these are the functions of the DBMS. So here are the functions. So we can create databases using a DBMS, and then we can create tables. So it is where we store the data. We store the data inside tables. So create supporting structures like indices, etc. Read database data. So again, it will be useless if we just store data. So the data we stored we should be able to read the data. Then we can also modify the data. So we can insert, update, or delete. Sorry with the spelling. Maintain database structures. So are we going to add more columns, etc.? Are we going to delete columns? So that's maintenance of database structure. We can also enforce rules. Like for example, there should be no duplicate, etc. Control concurrency. So what will happen if, let's say, we're retrieving several the same record? Many users are retrieving the same record, so this will be controlled by the DBMS. And the DBMS will also provide security, and these topics will be discussed by, of course, some of you later on. And then also we can we can also use a DBMS to perform data backup and recovery. Referential integrity constraints. A DBMS can enforce many constraints. A referential integrity constraints ensure that the value of a column in one table are valid based on the values in another table. I don't know if we have example on the next slide. So let's go back. So let's say, for example, we have two tables. We have an employee table and a department table. And inside the employee table, we have a column, department number, which is actually we can use that to reference to the department table. So what if you enter a value that is not inside the department table? It is not really a department number. It's a wrong department number. Then that should be checked. So these are what we call referential integrity. And I believe we have a topic for that in your next lessons. Database applications. The database application is a set of one or more computer programs or websites that serve as an intermediary between the user and the DBMS. So again, Facebook, Lazada, these are examples of database applications. Or let's say, for example, in the school, we have the School Automate, which is a school system. Then that's an example of database application. We also have what we call personal database systems. personal database system typically support one application, have only a few tables, are simple in design, involve only one computer, and support one user at a time. So usually we use this for if you're trying to develop something, and we can first use the personal database before we make use of the production database. So database system. So here we have here so example of a personal database or other personal DBMS, although access can be also opened by several users, but here's an example. So we have the user, then in this example, the database application and the database management system is actually rolled into one, just like Microsoft Access and also other personal DBMS. And then both of these now will react to the database. Enterprise level database systems. So enterprise level database systems typically support several users simultaneously. Of course, if we're talking about enterprise, we're talking about big companies. We have many employees, many users, etc. Support more than one application. So each department may be using another application. Maybe the managers are using other applications. So involve multiple computers. Sometimes we can have several servers, are complex in design, have many tables, and maybe have many databases. So you can just imagine how complex an enterprise level database system is. So here's an example. So we have here users, we have several database applications, and all of these applications are interacting with the database management system. So examples of these are Oracle, SQL Server, MySQL, DB2, etc. And the database management system is interacting with maybe the database or multiple databases. Data design terminology. So definitions. An entity, so these are the things that you should remember. An entity is a person, place, thing, or event for which data is collected and maintained. So if you want to collect data about this thing or about this place or about this event or about this person, then that's an entity. So in a school, for example, the student is an entity because we want to collect records or data about the student, the subject, the faculty, and others. So a field is a single characteristic or fact about an entity. So let's say, for example, the student is an entity. Then what are the fields? The fields are, so what are the data that we would like to collect from the student? So we would like to know their names, addresses, birth date, etc. So these are the fields. Then record, a collection of fields that describes one instance of an entity. So let's say, for example, Pedro lives in Maluwod, Pangasinan, Maluwod, Dagupan City, for example. Birth date is January 1, year 2000. Then these are the fields. So we collect all of these fields for that particular person. Then that is the record. Then file and table, a set of records that contains data about specific entity. So we have a record of Pedro, we have a record of Pablo, we have the record of Maria, we have the record of Policarpio, etc. So if we collect them, then we have the table. So it is a set of records. We collect the records, we have the table. So again, entity, these are the student. So the entity is composed of fields. And the fields, we can provide data for this field. And if we collect the fields or the data from the several fields of a single instance of an entity or single person, for example, in that matter, then that is a record. If we collect the records, then we have the file and table. I hope you understand the hierarchy. So anyway, here's an example. So we have here an entity, customer. So we have here several fields or attributes. So we have customer ID, first name, last name, address, city, state, zip, and email address. And then of course we have the values. And for the first row, We have MOR 9117, James Morgan, etc. So if we collect all of this data, this field, we have a record. Then, so in this case, we have 3 records. If we collect all of these records, or the set of these records is now called the table. Key fields. So one thing that we should remember is about keys. So the keys are used to organize, access, and maintain data structures. So there are 4 types of keys, actually sometimes more, but these are the basic types of keys: primary key, candidate keys, foreign keys, and secondary keys. Primary key is a field or combinations of fields that uniquely so that's what is important here. It should be unique excuse me, and minimal. So minimally identifies each member of entity. So for example, if in a student, we have a table, or we have an entity student, and then most probably the field that will identify the student, or the primary key that will identify the student, is each student number. So the student number should be unique, and it is also minimal. Maybe you can say that we can also use the name of the student plus the address of the student plus the birth date, for example. So if we combine this, maybe it can be unique, but it is now very lengthy, so it is not anymore minimal. A primary key is composed of more than one field. A primary key that is composed of more than one field is called a multi-valued key. So it's also possible to combine several fields to form the primary key, just like what I've said a while ago. But of course, that is not a good primary key because it is not minimal. Then candidate keys, any field that could serve as a primary key. So that means it is also unique, but it is not used as a primary key. Excuse me. So any field that is not a primary key or candidate, and these are now referring to non-key fields. So again, a candidate key is just like a primary key, but it is not used as a primary key. How is that? What's an example of that? Let's say, for example, assuming we all now have our national ID. So all students have their national ID. But in our database, for example, we would like to use their student number as that's the primary key. So the student number is the primary key, but we also stored their national ID number. And the national ID number is unique. But since we did not use the national ID number as our primary key, then we can say that the national ID is our candidate key. Foreign keys, a field in one file that matches a primary key value in another file. So a foreign key need not be unique. But of course, we are referring it to a primary key of another table, so that it is unique on the other table. But in the current table where the foreign key is placed, then it should not be unique. Let's say again, I have an example a while ago. We have employee table and we have a department table. So in the employee table, we have a field department ID, and in our department table, we also have department ID. And in the department table, the department ID is actually the primary key. But in our employee table, the department ID is just the foreign key because we use that to match to the primary key of the department table. So that's called the foreign key. We'll have examples in the illustration later. Field or combinations of fields that can be used to access or retrieve records. It's a secondary key. A secondary key do not need to be unique, but we can use them to retrieve or access records. Examples are your names. So let's say I want to see the record of Pedro Di Magiba, for example. So I can use the name, but of course sometimes the names are not unique. So that's an example of a secondary key. So here's an example. So let's take a look at the first table. We have the student table, composed of the following fields. So student number is unique, so therefore it is our primary key. Student name is not unique, but we can use this also to retrieve the records of the student, so we call that our secondary key. Excuse me. And then we have here the advisor number. Later on, we'll go back to that. We have the advisor table here. So the advisor number is a unique field, so it's our primary key. We have the social security number of the advisor, which is also unique, but it is not used as our primary key, so it is called the candidate key. And we have the advisor name, which also can be used to retrieve this record, but it may not be unique. That's why it's just a secondary key. And then you notice here that the advisor number, we have here advisor number also in our student table, but here it is possible that it is not unique, but this is actually what we call the foreign key. So we match this to the primary key of another table. Okay, so courses, for example here, courses, we have the courses or subject description, and the number of credits. Then grade table, you have the student number, course ID, grade. So what's the primary key here? The primary key here is the combination of these two. You notice it cannot be student number only, because if the student have 3 courses or 3 subjects, or actually in this case 4 subjects, then his student number will be repeated. But if we combine it here, then it becomes unique. We cannot also use course ID, because if there are 10 students enrolled in this particular course, then we can have 10 instances of this. So combining, if we combine both, this is the primary key. But if we use only one, this is now our foreign key, because we can match this with the student number of a student table. We can match this with the course ID of the course table. And you notice that we can relate this with this, we can relate this with this, and we can relate this with this. That's why we call it the relational database. And how do we design tables like this? That is why we have a topic called database normalization.